Jupiter is a cosmic monster unlike anything else in our solar system. It's a world so staggeringly vast that it could swallow more than 1,300 Earths whole. It is wrapped in storms that eat continents, surrounded by an invisible ocean of lethal radiation, and harboring depths so hostile that even NASA remains terrified of what lies beneath. In fact, NASA once spent billions of dollars building a state-of-the-art spacecraft, sent it on a 14-year voyage to the gas giant, and then deliberately ordered it to commit suicide by driving straight into the planet's crushing jaws. Not because it failed, but because Jupiter itself had become too dangerous. In September of 2003, after nearly 14 years of exploring the giant planet, the Galileo spacecraft made its final journey. Scientists guided it directly into Jupiter's atmosphere, where it vanished forever. The spacecraft had cost billions of dollars. It had traveled hundreds of millions of miles and transformed our understanding of the outer solar system. Yet NASA chose to end its mission in fire. Why? To answer that question, we must travel to a world where ordinary rules begin to fall apart. Because Jupiter is not simply a bigger version of Earth, it is something entirely different. At first glance, Jupiter appears familiar enough. Bands of clouds wrap around the planet like painted ribbons. Great storms swirl endlessly through its skies. Lightning flashes deep within its atmosphere. But Jupiter has no true surface. No mountains, no oceans, no solid ground where a human being could ever stand. If you attempted to descend into Jupiter, there would be no moment where your feet touched the land. You would simply keep falling, deeper and deeper into a planet that becomes stranger the farther you go. Years ago, NASA wanted to understand what Jupiter was truly made of. Scientists believed the giant planet should be rich in water. After all, Jupiter formed far beyond the young Sun, in a region cold enough for ice to survive. It should have gathered enormous amounts of frozen water as it grew. So in the 1990s, NASA sent a probe directly into Jupiter's atmosphere. Scientists expected violent storms, thick clouds, and large amounts of water vapor. Instead, Jupiter gave them a surprise. The atmosphere was strangely calm, hotter than expected, and unbelievably dry. The probe recorded winds moving at over 600 kilometers per hour. Even more strangely, those winds did not slow down as the spacecraft descended. They remained powerful, relentless, as if the entire planet itself were breathing. And the water? There was far less than anyone expected. For years, scientists struggled to understand how this giant world could appear so dry. Eventually, they discovered the truth. The probe had simply been unlucky. By pure chance, it had entered one of Jupiter's rare hotspots, unusual regions where clouds break apart, heat escapes from deep below, and dry air sinks downward. In simple terms, NASA had accidentally landed in Jupiter's version of a desert. It would be like visiting Earth, landing in the Sahara Desert, and deciding the whole planet had no water. Yet even as scientists puzzled over these strange results, something even more astonishing was becoming clear. Jupiter's atmosphere is not shallow. It stretches thousands of kilometers downward. And somewhere far below the colorful clouds, matter itself begins to change. On Earth, hydrogen is a weightless, invisible gas. But deep within the bowels of Jupiter, the sheer weight of the atmosphere alters the laws of chemistry. Under millions of atmospheres of pressure, hydrogen transforms into a glowing, churning ocean of liquid metal. This superheated, electrically charged matrix swirls in the pitch black at temperatures exceeding 10,000 degrees Celsius, far hotter than the surface of vulcanized lava, and hot enough to instantly vaporize any alloy humanity is capable of forging. And the pressure? Almost beyond imagination. Millions of times stronger than what we experience on Earth. No submarine could survive it. No machine we have ever built could endure it. Yet this strange metallic ocean may explain one of Jupiter's greatest mysteries: its magnetic field. Earth has a magnetic field. It protects us from harmful radiation coming from space. But Jupiter's magnetic field is monstrous, around 20,000 times stronger than Earth's. It stretches millions of kilometers into space, creating an invisible shield so enormous that it could swallow several planets whole. Inside this magnetic bubble, particles race at incredible speeds. Radiation becomes deadly. Electronics begin to fail. Even the toughest spacecraft slowly break apart. Galileo learned this the hard way. Though carefully protected with heavy shielding, the spacecraft slowly suffered damage year after year. Its cameras weakened. Instruments failed. Memory systems began making errors. By the end of its mission, Galileo had absorbed radiation equal to tens of millions of dental X-rays, enough to destroy a human being many times over. And yet, Jupiter still had more surprises waiting. For decades, scientists believed Jupiter had a solid core buried deep inside, a dense center of rock and ice. It made sense. After all, giant planets must begin somewhere. Surely Jupiter had formed around a hard center before gathering all that gas around itself. But then came a spacecraft called Juno. Launched by NASA and arriving at Jupiter in 2016, Juno carried instruments capable of peering deeper into the giant planet than ever before. And what it discovered shocked scientists. Jupiter's core does not appear solid. It is not a giant rocky ball sitting neatly at the center. Instead, it seems blurry, spread out, almost dissolved. Scientists now describe it as a fuzzy core. Heavy material appears mixed into the surrounding layers, blending slowly into Jupiter's strange metallic interior. No clear boundary, no simple answer, only questions. Perhaps Jupiter suffered a massive collision long ago, struck by a giant world early in its life. Or perhaps this strange structure formed naturally over billions of years. For now, nobody knows. And that uncertainty is part of the reason Jupiter remains so mysterious. But the greatest challenge of all is this: Jupiter destroys anything that dares to come too close. The deeper a spacecraft travels, the worse things become. Radiation tears apart electronics, heat rises, pressure becomes crushing. NASA's atmospheric probe survived for only 57 minutes before silence took over. And even then, it had barely scratched the surface. The probe reached pressures around 23 times stronger than Earth's atmosphere. That may sound extreme, but compared to Jupiter's deeper layers, it was almost nothing. To explore farther down, scientists would need a machine capable of surviving pressures more than 1,000,000 times greater. No such machine exists. Even if humanity somehow built one, another problem would remain: communication. How would a signal escape? Deep inside Jupiter, metallic hydrogen blocks radio waves. Any message from below would likely vanish into silence. Scientists imagine chains of relay probes passing information upward like whispers through the darkness. But such ideas remain dreams for now. Too expensive, too difficult, too dangerous. Yet Jupiter's dangers are not only found within the planet itself, they also orbit around it. Jupiter has nearly 100 moons. Most are small and frozen, but 4 stand apart: Io, Europa, Ganymede, and Callisto. These are not ordinary moons, they are worlds. Io burns with endless volcanic eruptions. Sulfur spills into space from giant volcanoes, feeding Jupiter's violent radiation belts. Ganymede is so large it is bigger than Mercury. But perhaps the most fascinating of them all is Europa. At first glance, Europa looks frozen and lifeless, a pale world covered in cracked ice. But beneath that frozen shell may lie something extraordinary: a vast ocean. An ocean deeper than anything on Earth, liquid water hidden beneath kilometers of ice. And where there's water, scientists must always ask the same question: could there be life? Tiny organisms, simple microbes, perhaps something stranger. We do not know, but the possibility is enough to make NASA extremely careful. And this brings us back to Galileo. By 2003, the spacecraft was dying. Its fuel was nearly gone. Eventually, gravity would pull it somewhere. And there was a small chance, tiny but real, that Galileo could crash into Europa. If a single stubborn Earth microbe hitchhiking to the spacecraft managed to survive the vacuum of space, it could contaminate Europa's pristine alien ocean forever, shattering our chances of ever finding true native extraterrestrial life. This was a catastrophic mistake science could never undo. To protect an alien ecosystem we hadn't even explored yet, NASA signed Galileo's death warrant. They steered the legendary craft directly into Jupiter's crushing atmosphere, watching in somber silence as billions of dollars of engineering vaporized into cosmic ash, destroyed to protect a moon we have not yet fully explored. Even now, Jupiter continues to surprise us. In 2017, Juno flew over the famous Great Red Spot, the giant storm visible even through small telescopes on Earth. Scientists once believed this storm existed only near the cloud tops. They were wrong. The storm stretches more than 350 kilometers downward, a giant spinning wound in Jupiter's atmosphere. For over a century, astronomers have watched it slowly become smaller. No one truly knows why. Perhaps one day, the Great Red Spot will disappear entirely. And if it does, humanity may witness the ending of a storm older than modern civilization itself. Meanwhile, near Jupiter's poles, Juno discovered something equally strange. Massive storms locked together in geometric patterns. Cyclones arranged like shapes drawn by an unseen hand. 8 surrounding one at the North Pole. 5 forming a pattern in the south. Stable, unmoving, beautiful, and entirely unexplained. Computer models struggle to understand them. Physics itself seems to grow uncertain here. Yet humanity has not given up. New missions are already on the way. Some will study Europa. Others will examine Jupiter's great moons in greater detail. Scientists continue to dream of deeper exploration. Perhaps one day, we will build machines strong enough to survive Jupiter's crushing depths. Perhaps one day, humanity will finally understand what lies hidden at its center. But for now, Jupiter remains patient. A giant world spinning silently in the darkness. Dangerous, beautiful, and still guarding many of its secrets. For every answer Jupiter gives us, it seems to ask another question in return. And perhaps that is why we keep returning to it. Because understanding Jupiter is, in many ways, understanding ourselves. How worlds form, how life survives, and how much of the universe still waits to be discovered.